Hello again. This is Math 2134 coming to you from the College of DuPage, and the title of this lecture is Economic Applications of Definite Integrals. Please be sure to be an active learner as you watch these videos. Recall from earlier in this book that a consumer demand curve is a graph of P equals D of X, and that's the one that you see here. Now it is a decreasing function because for a lower price, more people will want to buy it, or people will want to buy more units. So that is this demand curve. Now, the demand curve is usually a decreasing function since the consumer expects to pay less per unit for large quantities of the product. Also recall we talked about a supplier supply curve, or a producer's supply curve, which is the graph of P equals S of X. Now this is the price per unit, P, that a producer is willing to accept for selling P units. Now it's usually an increasing function because a higher price per unit is an incentive for the producer to make more units available. Also, the number of sellers or providers will increase if there's an opportunity for them to make a lot of money. Now, for commodities, there's a point called an equilibrium point, X sub E, P sub E, which is the intersection of these two curves. Now, this is only true for commodities, but then many people can make commodities. So the equilibrium point is where the demand curve intersects the supply curve, and that is the market equilibrium point, or the equilibrium point. Now suppose that on this demand curve, 1 unit will cost $8.75. Now it turns out that that's how much this costs, but the consumer, if we're talking about one consumer or the marketplace in general, could be willing to spend more money up here. But how much money was made then here? How much did the consumer have to pay? So it is 1 times 875, and so that's the area of this blue one. But you see they would be willing to pay for less units. They would be willing to pay a higher price. So they got to keep this money over up here. That was the consumer surplus. Now let's suppose that instead of, we're going to be talking about the same curve, but instead of them buying 1 unit, they bought 2. And the price now is $7.50 instead of $8.75. So you see now, how much did the consumer have to pay? Well, they bought 2 units for $7.50, so this area is going to be 15 of the rectangle. But you see, they would have been willing to pay more for less, and so they saved this money that they would be paying up here if they had bought in this area. That's called the consumer surplus, just like this is called the consumer surplus. And in general, what happens is we have a demand curve, and we have this rectangle, and this rectangle in this picture is going to be P times Q. And the area above that, under the demand curve, but above this rectangle, is going to be called the consumer surplus. And here's the definition then. That's the background, but let P equal D of X describe the demand function for a product. Then the consumer surplus for Q units of the product at a price P per unit is, we have the area under the curve, and then we subtract off the area under the rectangle, which is QP. So this is the definition of the consumer surplus. Let's look at an example though. Suppose that Arnold is shopping for high quality sketch pads for his art class. His demand function is given by P equal D of X equal X minus 6 whole squared. Now that is part of a parabola opening up, goes down, it kisses at 6, and then it goes up again. Now we're limiting this though to only the area where the demand is positive So we're looking at this place where this remains a decreasing function. And we see that a point on the curve is 2, comma 16, because if we put 2 in here, this would be minus 4 whole squared, which would be 16. So if this Arnold buys 2 of these, they will buy 2 for $16, and that will be, and their expenditure then will be 2 times 16, or 32, and that will be the area here. But there's an area up here that's going to be the consumer surplus. Okay, so let's look at the solution then. So at x equal 2, he pays 16, as we said. So what is his consumer surplus? Well, by our formula, it's going to be the integral from 0 to 2 of x minus 6 whole squared dx minus 2 times 16. So we have this definite integral minus 32. Here we add 1 to the exponent, divide by the new exponent. We pull the 12 out. We add 1 to the exponent, divide by the new exponent, and here we have 36, and the antiderivative of that is going to be 36x. We evaluate at the top limit, subtract off it at the bottom limit, and subtract 32. Here's at the top limit, minus here's the bottom limit. We subtract 32. We do the calculations, and we get $18.67. So the answer to this problem is that Arnold's consumer surplus is $18.67. Now, similarly, there can be a supplier surplus. You see here, the supplier is selling 1 unit for $5.75. So what they are making, their total receipts, is the area of this rectangle. But you see, there were some people who would have paid lower prices, and they could have been selling it for a lower price down here. So this is going to be what they were willing to sell some of this product for. So you see, the rectangle is how much they made, and they made more than they could have because they could have been selling it for these prices here. Similarly, if we go to 2 at 750, then what happens is the area here is 15, but some would have been willing to pay, and they would have been willing to also do these things for a lower price, and so this is how much more they made. This is called the producer's surplus. Generalizing the idea, if the graph of a supply function is a curve, as shown on the right, then a producer sells Q units at P dollars per item. The total receipts are QP. The producer surplus is the total receipts, which was Q times P, minus the area under the curve. And the area under the curve, of course, is going to be the definite integral from 0 to Q of S of x dx. This motivates the following definition. So if P equals S of x is a supply function for a product, then the producer surplus for Q units of the product at price P is the area of the rectangle, QP, minus the integral from, definite integral from 0 up to Q, S of x dx. Let's do an example. So suppose that this art supply store sells the sketch pads, and its supply function for this product is given by P equals S of x equal 1/3 x squared plus x plus 3. So this is their supply curve. Find the producer's surplus when Garvin Art Supplies sells 2 sketch pads. Well, at x equal 2, we substitute 2 into this equation. We find out that this point is 632, or 633, I guess. I'm sorry, I misread that, per sketch pad. So if they sell 2 sketch pads at that, its producer's surplus is, we're using just the definition, it is 2 times that point of 6.33 minus the integral under the curve. And it's going to be the green answer because it's the rectangle minus the area under the curve. And so we integrate from 0 to 2, and that's going to be 12.66 minus And here we add 1 to the exponent and divide by the new exponent in each case. Evaluated at 2 and subtract off at 0. Here we're evaluating at 2, and here we're doing 0. And notice that we have to be careful with our signs because this is a minus times a minus. You do the calculation and you'll get that the producer surplus is 3.77. Now, let's talk a little bit about the equilibrium point and these two concepts that we had. So the equilibrium point is the point at where the supply and demand intersect. This is the ideal point at which buyers and sellers come together and purchases and sales actually occur. It's driven by the marketplace, and this is true for commodities. In the example involving Louise in the movie theater, suppose that the theater charges $5.75 for one ticket and Louise sees one movie. Since seeing one movie was actually worth $9.38 to Louise, the difference between that is her consumer surplus. To her, this is a good deal since she paid less than she was willing to pay. However, the theater lost revenue by undercharging her. At $7.50 per ticket, the demand and the theater's curve intersect. This point is advantageous for both Louise and the theater because she is willing to see two movies at $7.50 per ticket, while the theater can increase its revenue by selling two tickets. It's a win-win. All right, let's do an example with this business equilibrium point. Then, so given Arnold's demand function, which was this, you remember from the earlier example, and the art supplies supply function, it's this. We're going to find the equilibrium point and explain what it represents. And we are assuming that x is less than or equal to 5 because we still want this to be a decreasing function. Okay, so we're going to set d of x equal s of x, and we're going to solve. So we're going to expand this quadratic and multiply both sides by 3, so on and so forth, get everything on the same side, and we get that this is a quadratic that's equal to 0. Now we can either factor this or use a quadratic formula, but what we find is where these two things intersect is at x sub e equal 3 is a solution. Now if we substitute 3 for x in the demand or the supply function, we find that P of E, demand or supply function, but we find out that this is 9. So you see this point then is 3, 9. That is the market equilibrium point. That's the quantity, that's the price. So the consumer's surplus is given by this minus that rectangle. You see, and we're showing both the consumer surplus and the producer's surplus here as well, but we'll just use the definition. So this is the definite integral from 0 to 3 of x minus 6 whole squared dx minus the area of the rectangle. So 3 times 9 is 27, and we evaluate this integral. We add 1 to the exponent, divide by the new exponents throughout, and we compute the definite integral, and we find out that this is $36. So the $36 then is Arnold's consumer surplus. Now, the supplier surplus is a different equation. It is going to be 3 times 9 minus this integral of the supply equation. So that's 27 minus, and it's minus the whole of this integral. And so you put minus and you evaluate the whole integral in here. And so we're going to add 1 to each exponent and divide by the new exponent. You should verify these calculations for yourself. And we have this. We evaluate this using the fundamental theorem of calculus. This is 27 minus. And then we have to, inside this bracket is all of this evaluation of the integral. So that's evaluated at 3 minus evaluated at 0. And you do want to be careful with your signs because this is a minus and that is a minus. And so we get 10.50. So we saw an example that if Arnold buys 2 sketch pads at $16 each, he spends 32, but would have been willing to spend up to 50.67, the area under the demand function. The difference 18.67 is his consumer surplus. Similar, we saw in example 2 that if Garvin Art Supplies sells 2 sketch pads at $6.33 per unit, it receives a revenue of $12.66, of which 3.77 is the producer surplus, a contribution to its overall profits. However, Arnold is willing to spend $9 per unit for 3 sketch pads, and they're willing to sell 3 at 9 units. That was the equilibrium point. At this point of equilibrium, Arnold spends more but gains more consumer surplus, while Garvin collects more revenue and gains more producer surplus. Both of them benefit from this transaction. It is a win-win. Now, a little background on this next concept. The question could be, what is a dead weight loss? A dead weight loss is a cost to society created by market inefficiencies, which occur when the supply and demand are out of equilibrium. Mainly used in economics, dead weight loss can be applied to any deficiency caused by an inefficient allocation of resources. So price ceilings, such as price controlled and rent controls, price floors, such as minimum wage and living wage laws, and taxation or tariffs can all potentially create dead weight losses. With a reduced level of trade, the allocation of resources in a society may also become inefficient. So here are some examples. For example, overvalued prices may lead to higher profits for the company, but it negatively affects consumers of the product. And that's true whether it is inelastic or elastic. The consumers will be reducing their spending, and they do not benefit, even though the companies might. Undervalued products may be desirable for consumers because they say, oh, I'm getting a good deal, but it may prevent a producer from recuperating their production costs. If the product remains undervalued for a substantial period of time, producers will either choose to no longer sell the product, up the price to the equilibrium, or may be forced out of the market entirely. Some important stuff here, both from a micro and a macro economics point of view. So let's talk about those, and specifically let's talk about price ceilings, price floors, and this concept of dead weight loss. And this little star means this is optional material, but we have plenty of time, and I want to teach you the best course that I possibly can. At the equilibrium point, PE is the most advantageous price for both consumers and producers for producing and selling XE product units of a product. However, circumstances may require that a price ceiling be imposed to protect consumers from getting price gouged, or that a price floor may be imposed to protect producers. For example, a city may impose rent-controlled, a price ceiling, to allow its residents to find affordable housing, or a country may impose a tariff, a price floor, to support one of its industries. Okay, so here are some hardcore definitions of that. A price ceiling is a price that is less than the equilibrium price. That means there's some inefficiency going on, but it is being established for that. And PC is the maximum price for which the product may be sold. Again, it's less than the equilibrium price. That's called a price ceiling. A price floor is a price, P sub F, and you see this is a higher price than the equilibrium price. And P sub F is the minimum price for which the product may be sold. So the loss in surplus is called the deadweight loss, and there's losses that happen from these two conditions. The following table summarizes how a price ceiling or price floor affects consumer surplus and producer surplus. Okay, so here's a picture showing this. This is the demand curve. This is the supply curve. They intersect at the equilibrium point. But then, now what we're going to do is we're going to impose a price ceiling. And we'll say this is the highest price that we can have. And you can see that's less than the equilibrium price. And so what happens then is this is the price at which things happen. And so you have, a rectangle and you have different areas there. So let's focus on this price ceiling then. And we see that this is the deadweight loss. That's the consumer surplus, and that is the producer surplus at that point. Okay, so let's talk about some facts then associated with this. The price ceiling is always less than the equilibrium price. The price ceiling intersects the supply curve at XC, PC, price ceiling, and PC is equal to S of XC. Now the new producer surplus is given by, we take the area of the rectangle, XC times PC, minus the integral from 0 to x sub c. Now we only go up to this price because that's where things happen. That is the price ceiling, S of x dx. The new consumer surplus is given by, we only integrate up to x c because that's associated with PC, and then it is minus xc times PC. And the deadweight loss is given by, we integrate from xc to xe, and this is the demand minus the supply. Similarly, if we have a price floor, we are saying the same kind of thing, except we're saying, this is the price floor. You can't go any lower than that. So that means this is going to be the consumer surplus, that's going to be the producer surplus, and the deadweight loss is there. So these are going to be the integrals again. So just to summarize what's in the table, the price floor is always greater than the equilibrium price. The price floor intersects the demand curve at XF, PF, where PF is equal to the demand at XF. And the new consumer surplus is given by the difference between this rectangle and this integral. The new producer surplus is given by the difference between this rectangle and this integral, and the deadweight loss is given by this calculation here. Let's do an example. In a small isolated mountain town, demand for propane is given by this demand function, and you can see that I've graphed that demand function here. And the supply function is given by this, so that's the increasing line, and that's the supply function. And X is representing in both those equations gallons per month per customer, and DX and SX are in dollars per gallon. So those are the price. So first thing we want to do is find the equilibrium price. Now that's going to be where these two intersect. So let's look over here to find the price. We set these two equal to each other, and we solve and we find out that X equilibrium is 11. And if we substitute that into the demand equation, D of 11 is 650. So that means this equilibrium point then is going to be 11 comma 375. This is not 650, this is 650 minus 0.025 times 11, that is the 375. So that is the equilibrium point that is out here, and that's what part A was asking about. Now it says find the consumer surplus and the producer surplus at that equilibrium point. Well, this is just what we studied before. So the consumer surplus is going to be the integral from 0 to 11 of the demand function minus the area of the rectangle, and we do the calculation, and you should verify that you can do these calculations, but we're going to get $15.13 if we round the answer off. The producer surplus is going to be the rectangle minus the integral, and this is the supply function. There's the area of the rectangle minus this, and we calculate that, and we get that this is 9.06 rounded. And so we see this picture. Now, assume that a price ceiling of $3, oh, and I guess actually, so that gets me through with this, and we're going to now go to part C. Okay, so here is part C. Assume that a price ceiling of $3 per gallon is imposed. Find this point. Well, to find where the price ceiling intersects the supply curve, we set S of x equal 3 and solve for x, and we get x is 6. So we have this point is 6, comma 3. And that's the answer to C. Now, part D says find the new producer surplus and the new consumer surplus with at this point. Okay, we're going to use the equations that we talked about. So with the price ceiling in effect, the new producer surplus is found by the area of this rectangle minus this integral. And we do the calculation and get $2.70. The new consumer surplus is the area between the demand curve and this point. So that's going to be this area minus the area of the rectangle. We do the computation and we get $16.50. Now the deadweight loss goes from 6 to 11. Those were the numbers that we came up with here. And we're going to be taking the demand minus the supply and calculating that integral. Now notice here you have a minus times a minus times this, so both those signs are going to be minus. We simplify and we compute the integral, and we get that this is $5. So that is the answer to part E for the deadweight loss. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. God bless you all.